The Sun is the most powerful force in our solar system, controlling Earth's climate and sustaining all life. Sometimes the Sun releases massive bursts of energy known as solar flares, which can disrupt Earth's atmosphere. These intense eruptions send charged particles and radiation hurtling toward our planet at unimaginable speeds. While most solar flares pass unnoticed, some have caused bizarre and extreme weather conditions on Earth. Throughout history, powerful solar storms have been linked to sudden temperature shifts and electrical disturbances. Some solar events have even knocked out power grids, altered jet streams, and triggered mysterious atmospheric anomalies. Scientists have long studied how solar flares impact Earth's weather, but many effects remain unexplained. The connection between solar activity and Earth's climate is complex, and each event provides new insights. In 1859, one of the largest solar storms ever recorded created auroras visible as far south as the Caribbean. This event, known as the Carrington event, was so powerful that telegraph machines sparked and caught fire. The storm disrupted Earth's magnetic field so severely that compasses became unreliable across the world. If a storm of this magnitude struck today, it could disable satellites, GPS systems, and power grids. In 1989, a massive solar flare caused a geomagnetic storm that shut down the power grid in Canada. Millions of people in Quebec were left in darkness as transformers overloaded and failed without warning. Scientists later discovered that the solar storm had created massive electrical currents beneath the Earth's surface. Radio signals were disrupted worldwide, and airline pilots reported strange disturbances while flying near the poles. During this event, auroras appeared in unexpected locations, including Texas and Florida, far from their usual range. In 1972, an intense solar flare caused an unexpected disturbance in Earth's upper atmosphere. Weather satellites recorded a sudden bulging effect, as if the atmosphere had been briefly pushed outward. Military radar systems detected unexplained disruptions, leading to confusion among defense officials. Scientists believe this flare temporarily altered high-altitude wind patterns, though the full extent remains unknown. During the Halloween solar storms of 2003, multiple massive flares erupted from the Sun within just 3 days. These solar storms caused severe disruptions to satellite communications and even affected power systems on Earth. Airline pilots flying over the Arctic reported strange turbulence and electronic malfunctions during their flights. Researchers found that the flares temporarily shifted jet streams, potentially influencing short-term weather conditions. In 1967, a powerful solar storm interfered with US military radar systems, nearly triggering a global crisis. Air Force bases mistakenly believed their radar networks were being jammed by enemy forces. At the height of the Cold War, tensions were high, and officials prepared for a potential nuclear response. Fortunately, solar scientists identified the true cause before any irreversible actions were taken. This event remains one of the most dramatic examples of how space weather can influence global security. In 2012, a solar flare erupted with the same intensity as the Carrington event, but narrowly missed Earth. Had this storm struck, it could have caused global blackouts and damaged power grids for months. NASA scientists later confirmed that Earth had avoided a potentially civilization-altering catastrophe by just a few days. This near miss highlighted the importance of space weather monitoring and early warning systems. In 2001, a massive solar flare unleashed an intense wave of energy that caused an Arctic heat wave. For several days, scientists recorded abnormal temperature increases and unusual shifts in wind patterns. This event raised new questions about how solar storms may influence regional climate systems. Researchers continue to study the relationship between solar activity and atmospheric changes on Earth. Solar flares not only disrupt technology but can also trigger powerful geomagnetic storms that impact Earth's climate. Some scientists believe that prolonged periods of solar activity can influence weather cycles over time. Historical records show patterns between solar maximum periods and fluctuations in global temperatures. During intense solar activity, Earth's atmosphere expands slightly, affecting wind patterns and jet streams. While these effects are still being studied, evidence suggests that the Sun plays a role in climate variability. The Sun follows an 11-year solar cycle, with periods of increased and decreased solar activity. During solar maximum, more sunspots and flares occur, increasing the likelihood of space weather disruptions. At solar minimum, the Sun is calmer, and Earth experiences fewer geomagnetic storms. However, even during low activity periods, a single powerful flare can still cause significant effects. The interaction between solar particles and Earth's magnetic field produces breathtaking auroras near the poles. In extreme cases, auroras can be seen much farther south, providing a rare spectacle in unexpected locations. The study of space weather has become more important as our reliance on technology increases. GPS satellites, power grids, and communication networks are all vulnerable to strong solar storms. Governments and space agencies are working to improve early warning systems for potentially hazardous solar events. In 2022, NASA launched the Parker Solar Probe to study the Sun's outer atmosphere up close. This mission aims to improve our understanding of solar flares and their potential impact on Earth. Other space agencies, including the European Space Agency, monitor solar activity using specialized space telescopes. These efforts help scientists predict when the next major solar storm could strike Earth. In recent years, concerns about a modern-day Carrington event have led to discussions about preparedness. Some researchers warn that without proper infrastructure protection, a major solar storm could cause economic devastation. Power grids could be offline for weeks, and satellite networks could take months to fully recover. Governments are investing in strategies to protect critical systems from extreme space weather events. Scientists are developing shielding technology to safeguard satellites and communication networks from solar radiation. Backup power systems are being tested to ensure vital infrastructure remains functional during solar storms. Despite advances in technology, predicting solar flares with absolute accuracy remains a challenge. Solar storms travel at varying speeds, making early warning times unpredictable for scientists and policymakers. Even a moderate solar flare can interfere with air traffic control, satellite navigation, and electronic devices. Pilots flying at high altitudes must take precautions during intense solar storms to avoid radiation exposure. Astronauts on the International Space Station also monitor solar activity to protect themselves from dangerous radiation. Understanding the connection between solar flares and Earth's atmosphere is crucial for future space exploration. If humans establish colonies on Mars or the Moon, solar storms could pose serious risks to astronauts. New technologies, such as solar shielding and underground habitats, may help protect future space travelers. The more we learn about the Sun, the better we can prepare for its unpredictable nature. While solar flares have caused disruptions in the past, they have also provided valuable scientific insights. Studying these events helps scientists uncover new details about the forces shaping our planet. Future missions will continue to explore the mysteries of the Sun and its impact on Earth's climate. Space weather is a growing field of research that could help prevent disasters in the coming decades. As solar activity increases in the current cycle, scientists remain on high alert for potential flares. The next big solar storm could happen at any time, altering life on Earth in ways we never expected. For now, we continue to watch the Sun, knowing that its power remains one of the greatest forces in our universe. Because when it comes to space weather, one massive flare could change everything we know about our world.